Hello everyone and welcome to MV Tutors. I'm Solo and I'll be looking at the IUPAC naming of organic compounds. Remember guys that if you need a tutorial session, please do comment below or visit our website mvtutors.co.za to make an appointment. Alright, so what is this IUPAC naming? First of all, what does IUPAC even mean? Alright, so it is the International Union of Pure and Applied Chemistry. Okay, the society has come together and they've decided there's a way in which we name these organic compounds. All right, and let's get right to how you name them. Well, first of all, you have a prefix to the name. All right, then you have the main portion of it, which is the root, and then the suffix. So what do each entail? The prefix, all right, it is the position and names of substituents. Okay, like side chains. Think about your alkyl groups, okay, your methyl, ethyl, and so forth. All right, and you list those alphabetically. So if you have a methyl and a ethyl, E comes before M, so you'll start with the ethyl. All right, then the root, well, it depends on the number of carbon atoms in the main chain. So you might have a carbon chain which has branches. You need to count which is the longest carbon chain, all right? And then pick that, and then from the number of carbons, you'll get what the root is. Sorry. And then the suffix, well, that is determined by the homologous series. Okay, so we're just going to do a little bit of, a little bit of a summary. You should know by now the homologous series from the previous video that figure did. All right, but yeah, let's start with the root and the suffix. Okay, so with the root, it depends on the number of carbon chains. All right, if you have one carbon, sorry, the number of carbon atoms in a chain. So all right, I like using the blue pen. Okay, so if you have, so I'm just going to start with the root. We'll get to the suffix later on and then end it off with the prefix. But if you have one carbon, okay, that would be meth. Okay, all right, and if you have two carbons, that is eth. All right, three carbons, that is prop. Okay, so for example, if you are looking at your homologous series, that is your suffix now. Okay, so your homologous series is indicated by the suffix. If you're looking at alkanes or your hydrocarbons, all right, alkanes as part of your hydrocarbons. All right, and then you had one carbon atom, so that would be methane. All right, ethane if you have two carbons, propane if you have three. All right, and then it goes on. If you have four carbons, it's bute. Okay, and if it is an alkane, it'll be butane. All right, then you have pent. Okay, it's easy to remember this because of a pentagon, so pent. Yeah, and then six, that's also easy to remember, it's hex. All right, seven is hept. 8 is oct. So like petrol, guys, going back to the hydrocarbons, petrol, it'll be octane. Okay, so the fuel there, that's a nice one to remember. Okay, and then 9, oh my gosh, I'm thinking of a nanagon. What is 9 again? Non. Okay, for a moment I forgot it. And then 10, thinking of a decagon, it's like deck. All right, yeah. Okay, so that is your root. Now when it comes to the suffix, like I said, it has to do with your homologous series. So if you're dealing with the hydrocarbons, you either have an alkane with a double bond, alkyne with a triple bond. Okay, Okay, and it's nice to note that alkanes are saturated. All right, we'll deal more with saturation and unsaturation, and alkenes and alkynes are not saturated. Okay, alkene with a double bond, alkyne with a triple bond, they can still be broken down and have more atoms added to it, but alkanes are saturated. You can't add any more atoms to it. Okay, so yeah, those are your hydrocarbons. Then you have halogens. Okay, where instead of a hydrogen, you would put a halogen. A halogen is in group 7, which could be chlorine, fluorine, bromine, iodine. Okay, so you have halogens, then you have alcohols. So instead of having a hydrogen hydrogen atom, you would have a hydroxide, OH. Okay, so that would be representative of your alcohols. All right. Whether it's a primary, secondary, tertiary alcohol, you'll see. But we'll deal with that. Okay, then we have your aldehydes, your ketones, your carboxylic acid. I'm just gonna end the carb there. Carboxylic acid, and then you have your ethanoates. What do you call that again? Your esters. Okay, so it is quite important for you to know when you start naming these compounds, organic compounds, which homologous series does this compound belong to, and how many carbon atoms do I have in the longest chain. All right, then you can get to the prefix. The prefix, if you have a branch on your longest carbon chain, okay, if it's one branch, I'll just do that. If it's one branch, you get a methyl. Okay, sorry, if in that one branch you have one carbon atom, it's a methyl. If in that branch you have two carbon atoms, it's called ethyl. Okay, if in that branch you have three, it'll be propyl. Okay, so really your prefix, it helps to know your root. It really does. It will assist you in knowing your branches and how many carbon atoms you have in that particular branch. All right, so yeah, now that we've covered that, the prefix, the root, and the suffix, let us go to the rules of naming the organic compounds. Okay, so first step, you must identify the functional group and the homologous series that this organic compound belongs to. Like if you have your hydrocarbons, you know you just have C atoms and H atoms. So if they're only single bonds, you know you have an alkane. If you have a double bond and a triple bond somewhere, you can either choose alkene or alkyne, all right? If you see an OH, you know you have an alcohol. If you see a COOH, you have a carboxylic acid. Basically identify what functional group you have, okay, right, or homologous series of that organic compound. Then step 2, find the longest chain of carbon atoms, all right, and it must include the functional group. So let's say you have a double bond, okay, and when you counted the longest carbon chain, if you have a string of carbons and there are branches to it, and the branched one has the longest carbon chain, you must ensure that the functional group is prioritized for you to say, okay, this is my longest carbon chain, this is the functional group in it. Okay, so that is key. Okay, find the longest chain and identify the functional group in that longest chain. Okay, and then the number of carbon atoms from the side nearest the functional group. So when you start numbering them, let's say you got a chain of carbon atoms, you have 6 carbon atoms there, and you see a functional group there, an aldehyde, a ketone, an ester. So where do you start numbering these carbon atoms? You start numbering from the side with the nearest functional group. Okay, that's where you start. So if you have an alkene, which will be a double bond, wherever your double bond is, start numbering from there, or closest. If your end carbon is closer to the double bond, you start numbering from there. All right. And then it says, in the case of alkanes or haloalkanes, all right, halo meaning you have an alkane and one of the hydrogen carbon, why do I like saying hydrogen carbon? One of the hydrogen atoms is substituted by a halogen, chlorine, bromine, iodine, yeah, one of those. So if you have an alkane or a haloalkane, you start numbering from the carbon nearest to the side chain. Okay, you start numbering from the carbon nearest to the side chain. Okay, so let's say you have 3 carbons in a straight line, all right, and then you have a chain. Okay, let's say 4 carbons. Okay, let me just try to demonstrate that. So you have 4 carbons, all right. You have single bonds everywhere, and you have hydrogen atoms. I'm not gonna write the H atoms there, but it's 4 carbon atoms, and it's a hydrocarbon because it's just hydrogen and carbon atoms. So I have an alkane, and what kind of alkane is it? 4 carbon atoms, that would be so butane. And then I have a branch, all right, or it's a side chain, okay, somewhere there. So where do I start numbering? I start numbering from the side closest to that side chain. So I would start here, 1, 2. Okay, maybe use a different colored pen to show the numbering. So this will be my first carbon, my second carbon, my third carbon, my fourth carbon. So whenever you have chains, guys, you're gonna prioritize the chain, okay, or a branch if you may. All right. And then indicate the position of the functional group. Okay, so if, for example, you had, what do you call this? If you had a double bond, okay, so functional group in this example, that would be an alkane, all right? But if you had an alkene, okay, because around every carbon atom you have to have 4 bonds, okay, because carbon is from the 4th group, so there are 4 bonds around it, 8 valence electrons around it, fulfilling the octet rule. Remember that. So so this one says indicate the position of the functional group. Now if I have a double bond here, I have an alkene now, right? 4 carbon atoms, so butene. And remember, I have that side chain or my branch, okay? So I will still number from the one closest to the branch, all right? But now when I get here, I know that my double bond is on the 3rd carbon, all right? So that's how you indicate the position of the functional group. So the double bond, or your alkene in this case, okay, would be on the 3rd carbon, okay? So that is what it means. And then step 3, determine if there are any substituents. Basically, are there any branches? Okay, your alkyls, basically methyl, ethyl, propyl, butyl. I haven't seen a pentyl or a butyl. That's just so long. All right, and if there are more than one, so let's say on a carbon chain, you have like 5 carbons, and you have a branch there, a branch there, and another branch which has like an ethyl, okay, something like that. So if there are more than one, write their names in alphabetical order. So I will start naming them from this side. I have the 1st carbon, 2nd carbon, 3rd carbon, 4th carbon, 5th carbon. Here I have a methyl, it's on carbon 2. On carbon 3, I also have another methyl because it's just 1 carbon in that branch. On the 4th one, I have 2 carbon atoms, so it's an ethyl. So E comes before M, so I would say 4 ethyl, comma, 2 comma 3 dimethyl, because I have 2 methyl groups, so it'll be di, all right? And then I have 1 ethyl group. But I will start with the ethyl because E comes before M. All right, let me just remove all of that. And yeah, again, determine if there are any substituents, branches, and if there are more than one, write their names in alphabetical order. And 4, yay, we're at the end. Name the organic compound. All right, so here we are. We're going to start with the first one with all those rules in mind. Now, let us name this. Okay, so first of all, step 1, we said that we need to, let's just go back to it, identify the functional group, right? Yes, identify the functional group. Step 2, find the longest chain of carbon atoms. So let's do it. I'm only seeing carbon atoms and hydrogen atoms, so I must have a hydrocarbon. I'm only seeing single bonds, so it is an alkane. Okay, so that is your suffix, right? Ane. Okay, now how many carbon atoms are there, or the longest carbon chain? All right, so I have 1, 2, 3, 4, 5, and I have 1, 2, 3, 4, 5, and I have 1, 2, 3, 4, 5. Oh my goodness. So all these longest chains have 5 carbons in them. Okay, then I start to think, okay, do I have a branch, an alkyl group? Probably, because I will start numbering my carbon atoms from that alkyl group. Okay, so depending on which chain I choose, if I take this chain, okay, I have 5 carbon atoms there. So if I were to straighten this chain out, I would have these 2 carbons, so it would look something like this. So I would have 1, 2, 3, 4, 5, right? And then on the third one, I would have 2 carbon chains, and on this carbon chain, I have another one. Okay, so this is looking quite complicated, all right? So my methyl, or my branch is on the third carbon. Okay, so that is option number 1. Okay, yeah, so it's on the third one. If I look at, if I look at this chain here, this straight one, still 5 carbon atoms. I have a branch chain here on the third carbon, and then I also have a branch there which could be on the 4th carbon or the 2nd carbon. All right, I would choose the 2nd carbon because, yeah, if I start numbering from the right to the left, it will be on the 2nd carbon. So currently this one is winning because it's on the 2nd carbon. All right, if it was, yeah, the previous one we looked at was on the 3rd carbon, and we prioritize in terms of the number. The one you want, when you choose where you start numbering, you want a number closest to the chain that you have, to the branch that you have rather. And I would start numbering this side because of this branch, but this is for that option. Okay, let's look at our last option. I have this one over here. Okay, so if I were to straighten this out, I have my first branch on the 2nd carbon and on the 3rd carbon. So option 2 and 3 are actually similar. I could choose each of them and I would get the same answer. But option 1, I'm not going to go with it because my branch is on the 3rd carbon. I'm going to go rather with the options where my branch is on the 2nd carbon. Okay, so we can take this option 3 or option 2. It will give us the same answer. But anyway, like we said, our suffix is ane because we have an alkane. And then we have 5 carbon atoms in the longest chain, and 5 is pent. So we have pentane. All right. Now, where are these branched carbons? Okay, so I'm just gonna choose the straight one. Oh man, okay. I'm just gonna choose the straight one because it's easier to read. Okay, my second option, which is the same as the third option. Okay, so I have pentane at the moment, right? Okay, now let me start numbering these carbon atoms. I'm going to start from the right. It's number 1. Ooh, what a number 1. 3, 4, 5. Okay, so on the second carbon, I have a methyl group, right? And then on the third carbon, I have an ethyl group. Ethyl comes before methyl, so it'll be 3 ethyl, 2 methyl pentane. Okay, we can breathe. Let's go to the next one. All right, so I have a lot of things going on here. I see I have a halogen, bromine. I have a branch, 2 branches actually, and I have a double bond. Okay, so this is like a haloalkane. No, I'm lying. There's a double bond, so it is a haloalkene. Okay, because I have a halogen and everything else, it's just hydrogen and carbon bonds. Then I have a double bond, so I know that it belongs to the homologous series of alkenes, right? So it will end with the ene. Okay, what did the rules say about when you have your halogens? Okay, where do we start numbering? Do you start numbering from this? Oh, let's get the longest chain before we even get to the halogen. Let's get the longest chain. So we have 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4. Nope. 1, 2, 3, 4, 5. Nope. So this is our longest chain. Okay, 6 carbon atoms. And we know that's hex. All right, so that is a hexene. All right. And then now let's talk, where do we start numbering? Do you start numbering where you have the double bond? Which one takes preference? Is it the numbering from the double bond, or is it the halogen, or is it the branch? Okay, we see our branches are in the middle, so that doesn't matter. But what do the rules say? What do they say? Let's just go back. So step 1 rather, we identified the functional group. It is a hexene. Okay, it's an alkene because of the double bond. Step 2, find the longest chain of carbon atoms. Yes, there were 6 of them, so hexene. And then the number of carbon atoms from the side nearest the functional group. Okay, cool. In the case of alkanes or haloalkanes, start numbering from the carbon nearest to the side chain. So here your branches take preference. Okay, we saw in our example the branches are somewhere in the middle. All right, and then indicate the position of the functional group. Yes, that will depend on the numbering. Okay, what does it say about halogens? Is there anything else about halogens? So determine if there are any substituents. If there are more than one, write their names in alphabetical order. Okay, there is a rule about what do you do with halogens. I'm gonna get back to you. Okay, guys, so it says number the carbon atoms. I missed that. Number the carbon atoms from the side nearest the functional group. Okay, so we're going to start where the double bond is. All right, so we're going to start numbering from here. This is our first carbon. Okay, first carbon, second, third, fourth, fifth, the sixth one. So we know it's a hexene. All right, so our hexene, our double bond is there at number 1. Okay, 1 hexene. All right, now we're gonna start with our halogen there. Okay, so currently our halogen is on the 5th carbon, so it will be 5 bromo. Okay, then we're gonna look at our branches. We have a methyl group there, we have another methyl group there, so it will be 3, 4, because on the 3rd carbon and on the 4th carbon, di, because there are 2 methyl groups, so dimethyl one hexene. Okay, that was hectic. Okay, so let's just recap. We started by identifying that we have a hexene, right? Okay, so it's not a fully, it's not really a hydrocarbon, it's not a pure hydrocarbon, it is a haloalkene. Okay, so we have a halogen, which is bromine, alkene because of the double bond, so haloalkene. And then we started numbering from the side closest to where we identified our functional group. So from the left to the right. And then we also identified our branches. It's methyls, okay, because it's just one carbon in each branch. And the methyl groups were on the third carbon and the fourth carbon. Our halogen was on the fifth carbon, and our double bond was on the first carbon. So, yeah. Yes, this is like our prefix right there, and then our root, and then our suffix. And that concludes that example. Okay, and then now we have what do you call this? It's like a circular chain. Is it even a chain? Do you call it a circular chain in this case? This is not a straight line chain, it's a ring. Yes, I was looking for the term ring, okay? And in this ring, so we have, I see there a double bond, and I'm seeing only hydrogen and carbon atoms, so we have an alkene, okay? So, ene. How many carbon atoms do we have? So we have 1, 2, 3, 4, 5, 6, so it's a hexene. All right, and we start numbering from where we can identify a functional group. So that'll be our first carbon, second carbon, third carbon, fourth, fifth, sixth. Okay, so that's fine. They join together, it's a ring. So in cases where you have a ring, it will be called a cyclo, okay? Cyclohexene. And here there's no need to say cyclo 1 hexene. It's, you just assume that because you have that double bond there, because you have the double bond there, it's the only double bond. There's nothing extra happening here. There are no branches or anything like that. So you can just say cyclohexene. So whenever you have ring carbons, please, cyclo is the key word, okay? And you must always make sure that around your carbon atoms you have 4 bonds. So we have 1, 2, 3, 4. Great. We have 1, 2, 3, 4, and so forth. Keep checking and keep counting. Okay, if you have 5, you've made an error. If you have 3, you're still wrong. All right, and now we coming to another one. So I see carbon atoms, hydrogen atoms, and I see oxygen. Okay, I see oxygen. I don't see double bonds with oxygen, so this should be an alcohol because of the OH. Okay, so I know I have an alcohol, and the suffix there would be all. Right, now let us count the number of carbon atoms. We have 1, 2, 3, 4, so that is bute, because, you know, 4 is bute. Okay, and where is this OH or our hydroxide? On which carbon is it? Okay, so I'm going to start numbering here. 1, 2, 3, 4, because we start numbering closest to our functional group, right? So it will be butane 2 all, because that OH is on the second carbon. So butane 2 all. All right. If it was on the first carbon, if your OH was on the first carbon, which would be your primary alcohol, you would just say butanol. But because it's on the second carbon, okay, with other 2 carbons on the side, it is a secondary alcohol, so that's butane 2-all. And I think we've come to the last one. Yes, our last example. Okay, so we need to identify the homologous series, functional group. Guys, whenever I see a carbon atom at the end, double bonded to oxygen and OH, this is what comes to mind, Cu. Maybe you've heard me say Cu. This is what I mean. All right, And when I think of Ku, I think of carboxylic acids. Okay, that's how I identify a carboxylic acid. So I know that I have a carboxylic acid. Okay. All right. Ooh. And then how many? Oh, I see I have a carboxylic acid. I also see that I have a methyl group. All right. And I have 3 carbons. So where will I start numbering? Definitely closest to my functional group. Okay, so you see you have 3 carbon atoms here, right? And it's the same. I mean, on the second carbon, it would be 1, 2, 3. On the second carbon, I have a branch. Okay, it's really the same as choosing this one here. Okay, so yeah, it's fine. So on the second one, I have a methyl group, my carboxylic acid, and I have 3 carbons. So it would be, okay, so 3 would be pent, right? Met, it, pent. No, not pent. What am I saying? Apologies, it's prop. It's prop. Pent is 5. So it's prop. So it will be a propanoic acid. All right. So it ends with acid. Oic acid is your suffix. Oic acid. Okay. We have 3 carbons. So it's propanoic acid. Okay. Propanoic acid. I'm not gonna say it's on the first one, like 1 propanoic acid or propan 1 oic acid. No, it's just propanoic acid. And then you have your methyl group on the second carbon atom. So it'll be 2 methyl propanoic acid. Okay, and yeah, that concludes our lesson. I wish I could do more, but because of time, we'll just stop it there. I hope you've learned and you can do it by yourself or on your own. Okay, just go through the steps and you'll be fine. All right, like I said, if you require tutoring, extra help, do comment below, or else visit our website and make an appointment. Thank you. Hi guys, just a bit of a correction with this example that I did there. Okay, so in real life, you'll never get a haloalkene. If you're going to add a halogen to an unsaturated organic compound, like an alkene here, okay, this double bond will break, okay, and then you'll have single bonds and therefore will have a haloalkane. So you can never have a haloalkene or a haloalkyne. It's only a haloalkane. If you're going to add halogens or any other atom that can be added through the process of addition, call it an addition reaction, then the double bonds or the triple bonds will break, but there's only haloalkanes. So I just did this example from the top of my head without thinking too much, that whenever you have a halogen, you will always have single bonds. All right, not a double bond. So yeah, something to be aware of and an error on my side. Thank you. Oh, and we will be covering the reactions that organic compounds go through. So you'll see that with alkanes, they go through substitution reactions because you can't add more to an alkane. It's already saturated. All right, but when you have double bonds and triple bonds, you can add to them and you can add whatever, okay? Whatever works. For example, you can add halogens and you get haloalkanes, or and the process will be called halogenation. Okay, so yes, in this case, there's no such thing as a haloalkene or a haloalkyne. It's only haloalkane.